Good morning, everybody. I'm AIRAGHI, and I worked during my postdoctoral research in the Origin project on the thermometry and crystal chemistry evolution of low-grade metamorphism in Central Pyrenees. I mainly focused on the Bielsa Massif, situated at the southern border of the axial zone, as you can see in the simplified geological map. In this massive, a distributed deformation is observed, formed by a dense net of melanitic corridors that alternate with lentils of relatively undeformed granite. And it is along the strain gradients that we have sampled for a detailed petrographic analysis. From undeformed to low-grade myelonites through refracted samples, all samples have been altered in green schistophasius conditions, and chloritization is one of the main alteration reactions. So we started in detailed chloride composition in order to be able to unravel possible different metamorphic events. We discovered two groups of chloride, one mainly preserved in undeformed samples and heterogeneous in composition, the second one crystallizing in cracks of deformed samples or replacing chloride-1 budans in myelonites. Empirical and multi-equilibrium thermobarometry indicated that the first group of chloride grew at about 350 degrees, while the second one grew at about 280 degrees. Uranium-lead titanite, anatase and monazite dating linked to chloride 1 and 2 also reveal that chloride 1 grew at about 270–300 million years, while the second group of chloride is much younger and grew at the Alpine time at about 40–50 million years. But we may wonder why, even in zones of high strain, the chloride composition is not totally re-equilibrated. And to answer this question, we use transmission electron microscopy and synchrotron, and we find out that the heterogeneous chloride composition observed in undeformed samples can be explained by the fact that at the nanoscale, fluid precede and evolve in local reservoirs through disconnected nanoporosity, while in deformed samples, a more pervasive but still discrete replacement of chloride 1 by chloride 2 could be explained by the fact that at the nanoscale cracks or nanocracks are linked and therefore allow a channelization of fluids at the grain boundaries. So in summary, our results show that the Bielsa-Variscan masses, although granitic in composition of low grade, still preserve two metamorphic events. One at the late Variscan, that is mainly preserved in the undeformed part of the granites, during which fluid mainly percolated the nanoporosity, and which changed deeply the rheological behavior of the massif for the next compressional phases, and the second one during the Alpine time, during which fluid was more channelized at all scales up to melanitic corridors and allowed as distributed deformation to form just before the localization of the deformation on the main thrusts as the Bielsa thrusts. Thank you for your attention.